Okay. Alrighty. Hi there, this is pretty insane. Allow me to fuss around fixing some of my stuff. Reason I'm showing up a little bit late today is because, as sometimes happens with OBS, everything broke between one day and the next, and I did nothing to change anything. However, it might have a positive end result. I'm not entirely sure, but we shall see. Because here's the thing, and I'm just fooling with my my black magic stuff. I can do things like this. I feel like this is going to be a weird day, but that's fine. I do have a plan. I'll get your chat up on screen as soon as I can. I'm trying various things, like, for instance, here's the other video thing. That don't work, but this did. So we'll remove that, and we're going to be using this going forwards. The difference between those two things is one of them was Blackmagic ATEM mini output. I know I'm not focused either, everything's all screwed. And that used to not work as far as inputting into the computer. It had to talk over a USB cable, and I can use the thing to adjust the cameras and stuff, and have been doing so, but it would not give me video. So I ran actually, come to think of it, what if I unplug this? Yep, there we go. I ran the HDMI output of that into the old converter that I have, which is another Blackmagic Thunderbolt device, which I had to run through a special adapter to get it into the computer. So I was using essentially two things into each other because the one didn't work. And that other one has just stopped working, and the one I was supposed to be using this entire time just started working, or at least seems like it has. Yep. Got visuals and everything. It might even look better if going through an additional layer of HDMI is bad. So here's the deal. I'm way behind schedule. I'm 10 minutes late because when I fired up the video streaming stuff, nothing happened. Total black screen. And this is me getting video back. I think it actually is working at this point. I'm pretty sure my audio works as I can see it. Although I need to, here, hang on, hold the phone. There we go. I normally turn up a little bit, sorry about that. I had a plan, but everybody has a plan until their technology hits them in the face. A slight modification of an old Mike Tyson quote. So instead, I will kind of improvise and figure out what the heck I'm doing, seeing as the technology punched me in the face. First thing I want to do is get my chat up, that being something I usually like. Oh, look, it's now doing new things. It showed me a thing saying it will do pinned chat. I don't care. I don't want to do pinned chat, YouTube. Leave me alone. YouTube is also periodically showing some kind of advertising thing in its little logo, and I don't know what that means either. Oh, I'm all the cranky today. Check this out. I can go to chat window, and everything dies. And you know why? Because the video capture device that I had was not the one we want. This is the one we want, and I have to resize it. There we go. That better be the correct resolution too, or I shall be pissed off. And this one has to go away now because it did not work and was not real. And then I have to get the chat window actually up. And it has to be on top of you folks on the screen. There we are. Hi. We got chat. We got something. I was going to make a cup of coffee. I swear to God I might. If that's okay with you folks. I feel like I'm going to need it. This is a bad day as far as being able to function and having things work. No fault of yours. No fault of mine. I did nothing to change any of this. So let me see what I can do as far as juggling things around. Because, you know, one of the things I was going to do, I have called this chat coding of a thing. Hang on. I'm distracted because I need to go to ATEM software control in order to focus. This is me focusing. There we go. And no, I don't need that anymore. Oh, someone's trying to hack your Apple ID. That sucks. No, this is all the weirder seeing as I have show and tell today on several different levels. You know what? I'm really going to need to make my cup of coffee. Shit, I don't know what to tell you. Well, I guess we'll see whether people show up. Here, I'll give you something to study. We're going to sit this somewhere where I can yell from the other room at it. I don't know whether that's a smart thing to do. There. Cables. Misbehavior. Technology. ARG. That's not going to work. Okay. Meanwhile, fire up camera 2. Sorry, that would be camera 3. Or is it camera 2? What are we trying to do? Oh. Sorry, folks. Fire up camera 2 when I plug it in. It was sitting around being unplugged. Like I said, I have show and tell, so I can take the time. Well, oh. Did that work? I feel like that didn't work. Do I even have the right camera? Which one do I want? Ah! Okay, camera 2 is showing, but it's not giving me anything. Come on. Come on, little camera. Come on, come on, come on. This is the good one. That might have been just my main. That would be bad. Let's unplug and replug all these guys. I'm getting blackness. Why am I getting blackness? This little bugger is definitely on. Why is it not communicating? What is your damn problem? Okay. Let's fire up put better lighting in case it needs that. That's exciting looking, but I can't get it. There's that. Are my cables dead? Is that it? Is it my cables are dead? Oh, I need my cup of coffee. Ah! Why? Why? Okay, that's the cam out. HDMI out. I shouldn't need, so it should still be alive. Or it would be alive if I have the real camera in there. Is this set to not? Yeah. Okay, still working on it. If I can only get this through to the machine. Yeah, it's still dead. If I can only get this through to the machine, it would look cool. I have something to show you guys. I'm just getting tortured by technology today. Hang on. You can have that. That's not black screen. I'm going to throw a log on the fire because I need to do that too. We got a snowstorm coming. We got a massive snowstorm coming, and it's going to be days of shoveling for me again. So that's going to put me behind the 8-ball. I'm not quite sure how well I'm going to be able to handle that. Flaming shit is falling in my room. You have to handle wood stoves with caution because they're dangerous things. I don't want to burn my crap down. Except for this other camera, I want to burn it. It's going to have to feel like you're watching an Andy Warhol. I could just not be streaming. That's what I feel like right now, is to not be streaming. Because check it out. You go to this. And I've got black screen. There's a camera there. It's showing something cool. I can't make it work. Ah! I'm gonna... I'll just try to get through all this because I don't really have much of a choice. I'm not sure whether it's an Andy Warhol film or a comedy film at this stage. Or maybe I'm just a dumb person that can't do things. I don't know. I mean, worst comes to worst, I'll just stop. But I don't want to because I really want to do this. Yeah, I'm in a wet dry knob and I'm on 0. Yeah, the thing I'm trying to give you a close-up of is this. So, little preview there. But in order to do that, I have to find out why the cable ain't working. So here's the thing. I'm gonna step away to make a cup of coffee. That's going to be a couple of minutes. I don't think I can put this in any kind of way that you can see it. That's bad. There, you're welcome. So plug in the HDMI. I can swivel this guy around while I fool with it. That doesn't do anything. That sensor resolution should be working for the other one. I know what I'll do. I'll test the other. I got another one I can test. Let's see. Aha! Oh, hey. That just flashed. Why did that flash? Why is... Okay. Amusing. There's no good reason for this to be happening. Okay. We're apparently going to flash while I make my coffee. Tell me... Yeah, post in the chat if the screen goes totally and completely black. This is a picture of my whole studio exploding. I'll give you something to do while the screen's dead and all. And it's still flashing. Why is it flashing? Is it flashing again? I don't know. So that one's alive. That one's alive when it's not flashing for no reason. That one's dead. Okay, next stage is to figure out why the one camera is dead and the other one is not, because the camera that's dead is the one that I can show you close-ups of the circuit board with, and that's kind of important. The coffee I'm making is pour-over coffee, so it's taking me minutes to make that too. So let's see now. So here's a cable. It's a spare cable now, because this stuff is not what you call hooked up. Yeah, so there. Here's the flashy one. I could be setting that differently, dude. I don't even care. Let's not worry about that right now. What I'd like to do is balance this on something. There. Now you can kind of see that. And then the next thing I should do is figure out why this one's dead, but I'm still making my coffee, so. Program today, I'll just have to tell you things about circuit boards and stuff. I don't know whether I'm going to be able to program or not. I mean, I've only blown a half an hour doing this, but it's kind of ridiculous. Oh, here. I can show you the box it came in. Maybe I'll spend the rest of the time putting this together. Yeah, this is a Mackie Micro Series 1202. This is a classic Mackie. This is the one that they wanted me to make the plugin for. So we shall see. It's like, now I have one. Now we can study it. I'm not hooked up right now to run it through and have us listen to it, but you know, there could be another day when I'm more able to do that. Right now I really need to get that thing working. Hey, live television. Got it off. Also, if I do end up able to do music of some sort, I'll probably be taking advantage of me being able to pitch my voice at this level. Because it's like, that's the kind of projection that you'd need in order to like sing and stuff. So the only reason I'm doing it now is because my lapel mic is like totally elsewhere in the room while I try to solve all these technical problems. So if I'm elsewhere in the house, I have to speak up so you can hear me. This does not sound like the classic Bob Ross Chris being really chill and mellow, but that's not today. Today is not that. But I'll tell you what I do have is my cup of coffee. So there's that. Now let's fix or solve what's wrong with this camera. This camera, the one that's dead. Firstly, if I unplug this wire completely, move this guy over. See, problem solving is, oh god, this is all tangled up. Problem solving is figuring out how to decode a problem. I've got a long video wire here. It's this wire that is giving me absolutely nothing. I can't tell whether it's the camera, or whether it's the wire, or whether it has something to do with the way that the entire recording system stopped working just now for no reason and swapped over from working with the ATEM Mini into a Thunderbolt Express thingy converter to directly from the ATEM Mini, which didn't work before. So all that changed. So what I need to do is, and this is kind of the morning, but not really. I'm going to run this cable over to this camera while it's unplugged and see whether that starts giving me picture. So here we go. Unplug the HDMI that was there before. Plug in this other one that used to work. Now if I go to 2, aha, okay, so here. So it's looking very much like one of my cables died, but to what end and on what end? So what we're going to do is unplug that, plug this into here, plug that into there, and see if anything changed. I've just swapped the position of these guys. I think when unplugging them, oh, trippy. Okay, I didn't expect that. Having swapped the position of these two, this one now came to life. This is the cable that I thought was dead. Oh, I've turned all the things on and off again several times. So if I unplug this and plug this in, that's now alive again. We might actually be getting to where I can show you the circuit board stuff I was telling you about. That said, I can't have it set up like this because there's a problem. This is now an input 2. Changing it swapped the, let's see, near. So that's one, that's supposed to be one. This is a wastebasket that I need to move underneath these things. If I can, maybe I can't. Oh God. Okay, that's good enough. So in unplugging and replugging the super long cable, it started to work with the other camera, so therefore we're now going to try making it work with the one that it was plugged into before without changing anything else. Do we have? And no, we totally don't. Okay. That's still alive. This is still alive. This is not. Yeah, that's true. I know that they don't like long runs, but it liked it before. That was the same cable that worked just then. So here's the thing. I think it might not actually not be the cable. I think this camera is somehow randomly set up to not work. So what I need to do is go back to our black screen, because when this cable was plugged in, that part was fine. So I'm thinking this is set in some way that I don't understand. Turn it off and on again, maybe? How you doing? That's showing me something weird. And you totally can't focus, can you? Let's set it to HD and see whether that's any better. I'm going to see whether I can't keep an eye on the screen. Yeah, it was working before. So that's what's puzzling me about this. My setup doesn't seem to be doing a damn thing. Oh wait, there's the setup thing. Primer displayed on screen. Totally light LED. It is set. The light is set to be engaged. Bluetooth not connected. Factory reset probably not what I need. Yeah, like right now, know that what you're OBS is getting this. This is alive. Where's my coffee? I still have to shout because I'm so far away from the microphone. OBS is getting this. This is live feed from a Blackmagic ATEM. I can also do this. This is live feed from the Blackmagic ATEM. The Blackmagic ATEM cannot do this video feed. And that is coming off of a cable that I just plugged into the other camera, and it was fine when it was in the other camera. And the one I'm trying to make work is the one that I can show you the circuit board stuff with. That said, I'm not convinced I absolutely have to do that today. As in, right now. Because I feel like I proved the cable works. Because I plugged it into another camera and it was fine. And I swapped things around and they were fine. And I have this camera running now and I can see on the back of the screen that it seems fine, but it's not giving me anything out of the HDMI output, and I don't know why. So I'm still fooling with it basically. Back to setup. Somewhere in here I had an option for resolution. Doesn't want to show me that anymore. I'm doing it wrong. Maybe it's on record. Yep. So I'm pretty sure that the thing is, like this, let's do another test, right? So here's what I can do. I was also counting these backwards. I'm touching my main camera feed now. Far is the cable that was working before. Near is a shorter cable connected to this. Now if I switch it to this, that means this input on the ATEM is alive. So I'm proving that the cable is fine. I'm proving that the input on the ATEM is okay. Everything that I've fooled with at this stage is proven to work. And again, back to here. There's even stuff I can do with this. Like here, you can see that these have different image qualities. I'll tell you why. It's because they're set with something. Namely, this is called ATEM software control, and if you were doing this kind of thing, you'd be able to use it, and this is how you do it. You have this camera option, and as you can see, the camera that I was using before, which you can't really see, well, that's always fun. That's not my, yeah. This looks a certain way and this looks a different way because they don't match, and I'll tell you why. It's because this one is set up with this tool, and I made the dark, it starts off like selected on lift, and then it goes to gain and gamma. What these things mean is lift is your dark stuff, gain is your brightest stuff, gamma is midtones. So what I've been doing this entire time, what like the Airwindows thing looks like, is, and you know what, hang on. I'm just going to continue to be cranky if I have to keep yelling this entire time. So this is me putting the mic back to near my face. And let me grab the correct mouse, switch it over. Yep. Mic goes here. So now I can start sounding a little bit more relaxed. Well, I tell you this. Let's see. Camera over screen. Now this has actually got things selected in a particular way where the position I'm choosing to pick the screen area is different. So I've got an area in the middle of the screen. So darkness is lift, brightness is gain, midtones is gamma, and I've been doing a thing, and I can do that with this channel 3 as well. As you can see, it doesn't actually match right now, but I can make it match, and I'll show you what that looks like. if I go to camera 3, and I don't have to select it, but if I go to camera 3 and make this be plus 0.06 on lift, and likewise with gain goes to 1.06 on red and 1.03 on green. And I don't think I have any changes in gamma right now. And at this point I can just quit out of this. Now, there's a similar tone color to things. Although if I'm not mistaken, I think probably what's happening is this camera is set to video and the other one is set to film. So let me fool with that. I'm going to take a moment and check, which means taking the microphone off again. Alrighty, so we're seeing this. If I go to the little 3 lines thing, which is menu, it's set to Ultra HD, and it is actually set to film dynamic range as well. So I'm not really quite sure what's going on there. Maybe I'll get more information when I look at the other one. I go to there, and I have that set the same way. So it's mysterious. Oh, hey, let me adjust the aperture, maybe? Yeah, so at this stage I don't know why this looks like this and then that looks like that. It feels, oh, actually no, I'm wrong. I do know why. I'll tell you why. Check this out. Lights. Now these look very similar. That's because I shut off the light that is right up in my face that I could show you if I had the other camera working that doesn't work. This one, see? The one that's black. And that's why this camera looks like this and the other one doesn't. It's because the main light that I have in scene is like up here. And we can't really see, you know what, I'm going to pull its plug. And here's the camera that's not working. So what we're trying to do is figure out how to make this thing work so that I can show you that circuit board. And this, literally this entire day is going to be derping around with cameras and being dismayed. Am I shouting? Yeah, I don't need to be this loud. I've got the microphone on this time. So I'll plug this guy in. Oh, hello. I thought of another test. I can do. It's a little cumbersome, but all the same, it's a test I can do. So hey, now we're going to get really funky. In that way of funky that's not really anything like being funky at all. Now what I'm wondering is whether maybe I can carry this around behind. Okay, goodbye. Yeah, I absolutely have used this camera previously, and it did work before. And not only that, the entire video system was set up differently and was working fine. Everything changed for no reason just this morning. Welcome to the world of technology. So, what I'm going to do is shut off this other camera, unplug its HDMI cable, take its power cable, plug that in, power it on, let's just set it up like this. I don't think it's going to fall over. I just extended one of the wires and okay, so the close-up camera now works when it's plugged into that stuff. What we have over here is the same wires and cameras and stuff that worked plugged into the other camera that didn't work when plugged into that right there. So yeah, this cable worked before, and the power supply at least was able to make it turn on, and that very same camera is the same one that's been giving me black screen. I haven't changed a thing. So now every single part of this situation works in a slightly different context. I can think of one further thing I can do. Back to here. So let's see, plug this guy back in, one-handed. Push the stand down. Last thing I'm going to do after I successfully plug this guy in and turn it on. And I still don't know why that's grayed out. I feel like I'm not satisfied with that part, so let me go and fix it. See, I set that to extended video. Not only that, I think I lost my color tone timing. Here, let me... just briefly get back into the microphone thing. So I think I just lost my color timing with it. Color timing is what people call these color correction things. So back into this and kind of reset these things, because I'm pretty sure when you do this, it's like sending the information over the HDMI cable. And since I power cycled it, it lost what I had in there. So now if I go back to the camera, now that has a comparable color timing with the slightly bluer darks and stuff like that. back out of that. Put the microphone over here again so that I can go and get another cable. Or go and... I can't tell whether it's another cable I'm trying to get or... I don't know what I'm doing. Here are the internet cables that I used to go to the extra... see, this is a Thunderbolt cable. And this goes from another Blackmagic device. Microphone. Give me a microphone. So this goes from another Blackmagic device. That's the one that I had before I had the ATEM Mini. And it's just an ordinary ATEM Mini. It's not the one that streams. Because I thought I could just run stuff into the computer and stream from there using OBS. That was my first mistake. So what I had was a Thunderbolt ATEM Intensity Shuttle, I believe is what the thing is. So what you have to do is go into this like $40 Apple adapter that will go from Thunderbolt to USB 3. And so I was running out of this HDMI cable out of the ATEM, which is a video mixer. And since it was not able to stream images for no reason that I could determine, I had to run out of the HDMI preview into an additional Blackmagic device that was explicitly for taking an HDMI anything. Originally that was an old Canon digital SLR, and turning that into Thunderbolt for going to older computers that had Thunderbolt ports, which went to this. So basically, I was going from camera to one Blackmagic thing, to HDMI, to a second Blackmagic thing, to Thunderbolt to Firewire adapter, and that's what I've been doing for months because my stuff doesn't work. So today, everything changed for no reason. Now the ATEM Mini sends me video input. I'm now in video capture device 2 rather than video capture device 1, because video capture device 1 was the Thunderbolt stuff. And also now the other camera doesn't work, or at least it wasn't working when I was trying it. So the next thing is more unplugging of the microphone. So here's the power adapter for the camera that I was using. And I can turn this on. That might have made a pop. I'm not sure if it did or not. That gives me both my pedal board turned on, but also that means I can plug this in here. The other plugging in was on a UPS that's for like my internet router. So the remaining question becomes this. Firstly, let me put the microphone back. I think we're getting to the end of this madness. Final thing is we got these going. That stuff works. The remaining camera is the one I need to use. It's this guy to show close-ups of things, like soldering. And the long cable was working in every other context. But the only thing that might have changed is maybe it doesn't want to be plugged into the UPS. Maybe the UPS is not giving it enough power to do HDMI. So this is a new connection. Can power it on, and I got nothing. Everything about this works in every other context. It just won't work with this camera plugged into this cable. Like, I mean, I can even focus it and everything, but wait, there's more. No, I can see on the back screen of this. Like at this stage, I might actually even be able to hold this up. Well, not while viewing through this one. See? The camera can see just fine. All the cameras match. The camera can see just fine. You can see on the back of it that the little screen is showing that it can see stuff. So the only thing that's remaining is, let me plug this cable from the back of the ATEM over the top of my typing keyboard and stuff into this HDMI input to see whether this madness is simply because this exact combination of cameras and cables and things is what's giving me trouble. So yeah, let me see. Firstly, I might have to take off the microphone. I have to go behind everything. Firstly, let me coil up that long cable. Unplug that one. We plug in this one. This is a nice short cable too, so this has the best chance of working. Every part of this worked in some other context. There's literally nothing here that hasn't worked every other combination. Let's flip this around. Now I've got this cable coming out. There. Come on, you. I'm trying to point it to something cool so that we can see it and then switch to its input. And we got it. It's alive. So now, while everything is still, all of this stuff is so in my way. Clearly it is the long cable that's not acceptable in this exact combination. In every other the other cameras were fine with it, but here's what I was going to do. Oh wait, I need to put my microphone back on. Yay! So I got a little work as far as getting HDMI cables that will work. And you can ask about EQs. I know you can't see yourself anymore. There we go. You can ask about EQs, by all means. I'm not at all sure whether I'm going to be able to code today. This is exhausting. Even drinking coffee is still exhausting. Although I do make wonderful coffee, I gotta say. Let's start talking about circuitry, because this is partly on the subject of getting the most recent channel to be more like a Mackie board, specifically this board that I have here. So what I'm going to want to do is fool with my tripod and stuff. I got to figure out how I can position myself around these wires and things so that I can still do anything. And I'm going to try to set it up so that this board is lit and that you can see what's on it. Other option is me holding it up. That is the sound of a tripod extending. I built this tripod myself out of what was originally a Manfrotto and 3 monopod legs called Targus TGMP6710, which I believe I got at Walmart. Not very glamorous. But you gotta improvise and build and make stuff. So let's see, this wire is not going to stretch very well. Ta-da! I may very well end up having to hold this up for you to be able to see any of it properly. But this is good enough to go with, I think. Scooch this stuff out of the way. Yeah, there's any number of ways of doing EQs. And price, yeah, what we can talk about that. One thing I don't know. I don't know whether I'm going to be able to do coding stuff today or not. This is one of the silliest, most grueling days I've seen in a long, long time. Sometimes that's just how it rolls. But right now what we're seeing is the world of a Mackie mixer. And let's see. We'll focus nicely. And the things I was going to talk about are how this is built. You can see through this because I have light shining through it. And though the illumination isn't very good, everything about this is such a clusterfluff of mess that I can't even apologize at this point. It's kind of got to suck it up and deal. So, U302, this is channel 3 that we're kind of focused on. And you can see these little things are capacitors. The ceramic disc capacitors, and what is here that I believe, I don't think we're going to be able to show it very well, but I can try. Oh no, wait, maybe this one. I'm trying to focus. Yeah, I can't let you see this because the light isn't the right direction. I'm sorry. Maybe if I rotate it around a little bit, I'm just holding it in the air. You can kind of almost see that. See, it's JRC NJM 4560. This board is filled with these things. It's an op amp. Op amp means operational amplifier. I'm trying to adjust brightness, but it's not doing it. Maybe I can. Oh, hey. That's as much as I'll get off of that. I need to throw more light on the subject, and I can't. So this is the secret to the sound of the Mackie 1202. And I've got some more information on it. Let's put this back down. Focus again. I made some notes. So the deal with this is this device is based on these guys. The NJM 4560 op amp. It's all through this mixer. In fact, I think this is just about the only amplification stage that this device has. And it is not a normal op amp. It's got some other stuff going on with it. I did a little research. So, gain bandwidth product is a measurement of how high a frequency it gets before the gain on the op amp it can be no more than unity gain. Op amps have limitations as to how high frequency they can go. A TL072 op amp will go up to maybe 3 megahertz, or 5.25 megahertz. OPA 2134 op amp, which is many times as expensive, will go up to 8 megahertz. NJM 4560D will go up to 10. It will extend upwards into frequencies that are like radio frequencies. So you could call it a bright op amp, but there's something else going on as well. Slew rate. You know about slew rate if you're an Airwindows follower and you use my plugins. Several of them, including Channel, manipulate slew rate in one way or another. And a TL072, which is a very typical op amp, 13 to 20 volt slew rate per microsecond. I believe the US is microsecond. OPA 2134 is another 20 volts per microsecond. Very fast. They're able to put a lot of energy through very quickly. NJM 4560D, 4 volts per microsecond. Not 20, 4. There are other op amps that are even slower than this. Oh, I'm sorry, I'm talking too loudly now. I'm so used to talking across the room. Let me quiet down a little bit. So, one of the things about this is, I'll back off the gain on that a little bit. One of the things about this is that with this limitation in slew rate, that's part of what gives these boards the sound that they have. All of these gain stages are based around these op amps. And the rest of this stuff, as you can see, there's not all that much to it. Like these capacitors, although you can't see them without me mangling everything around a lot again, this signal passes through these. They are, let me remind myself, looking at the wrong side. They're 22 microfarad, 25 volt. Now often with stuff like this, and again, these are the capacitors I'm talking about, these little cylinders here. Often when you've got something like that going on, I'm not showing it very well. There's one in the center. They're electrolytic capacitors. You can see the minus sign there. People will choose the smallest, cheapest ones that you can. I would not call 22 microfarad and 25 volts the smallest, cheapest one that they could. I don't think that's true. I think this circuit would run on a lower voltage. It's not necessarily running on 25 volt rails. It feels like what's going on here is they were able to buy a mass quantity of these, and everything seems to be built around them. Like, I can't find other sizes of capacitors anywhere. Oh, wait, no, I lie. There's one. This is a different size. This is a... Here, I'll just pick it up. Oh, I can hardly see. All the lights are in the wrong place. 470. And that looks to me like it says 16, unless it's 10. And this is with my glasses, so I'm in big trouble now. So yeah, these guys that you can't hardly see, but there it is. Those are somewhat larger, but most of these are 22 microfarad and 25 volts. This is not 25 volts. This is more akin to what the actual voltage limitations of the circuit are. And here's some 50 volt, 47 microfarad. This is part of the circuitry for powering the microphones. So the mic ends, that's part of where phantom power comes from. We've got transistors in here. I have no chance of seeing what those are without putting on more close-up glasses and having a completely different lighting situation, so I'm not even going to try. All of this stuff is what gives a board its sound. But it's not just that. You hold this like this. Maybe, hang on. So all this stuff is what gives a board its sound. And you can kind of see, you know, op amp, knobs go here, stuff goes through the capacitor here. You can almost see where this capacitor sits and where this trace goes up here, and presumably goes to either part of this capacitor. There's two leads coming off of a capacitor and then back out the other side. So there's going to be two spots on there. Let me go and find it from the other side here. It was this one. And sure enough, see this one? So that's how it works, is signals coming from the other side of the board to one end of this, and then coming out of the other end and going, as you can see, from here to here to here. And this is all pretty normal. But there's observations about this. Oh no, have we lost connection? There ain't nothing but trouble today. Oh no, it came back. I think. I can't really tell. I'll just have to keep going. If the connection dies, that's like not the first thing that's gone wrong today, so whatever. Let's see. Here's something you might not have spotted about this. See how these wires run? In a lot of cases, there's a number of things about this that are important as far as the sound of the board is concerned. And this is all of what I was wanting to do today as far as talking about this board. The wires are running kind of in lines. They're not going all over the place. They're tending to go in continuous lines. Some of the traces are fairly heavy as well. You can see that. These are not the tiniest traces you could possibly make, but also you can see through this board. You can see these traces are on one side, and then you can kind of see underneath there, those lines going this direction are on the opposite side. There are these lines here. And there's room for a lot of stuff going on in here, but the main paths that circuits go are aligned in a certain way. See, focus again. If signal goes this direction and another signal is going across it, they don't interfere with each other. If signal is going this direction and another signal is running alongside it in the same orientation and nearby it, they can affect each other. And this is in part inductance, but it is also because electricity is not actually contained within these traces. And this is something that I learned watching videos on printed circuit board design. It's very enlightening. When people talking about how they avoided having interference and noise coming into analog circuits on circuit boards that contain both analog and digital circuits, and also how you prevent having your circuit boards producing interference that makes them not able to be put in things like cars and airplanes. Because you gotta keep digital circuitry from generating interference if you're coming up with circuit designs that will go into airplanes. You're not allowed to just have stuff that'll produce a bunch of interference because it's considered very important that you don't. So one thing that we can see about this board, just from looking at it this way, this board does not have what's called a ground plane. A ground plane is an area of copper inside the board. And you can see this is a very simple primitive board. It's actually a fairly thick board compared to modern ones. And the circuitry is only on either side, and there's not much of it. Most of this board is like transparent. You can see right through where the wires go. There are virtually no ground planes anywhere in here. Now, how that matters is, I thought, quite interesting. It's why I wanted to talk about it. Oh, also you can see some other cute things in here. For instance, let's look at the power supply area. Come on, focus. There you go. These are diodes, the black things that are a little bit larger. They're power diodes, meaning that you can generate from AC power coming in or whatever, or step-down transformer power. You generate DC out of these. And this is a big, big capacitor that helps to smooth stuff out. These are like little fuse-like things. This single line means it's like a 0 ohm resistor. It is one way of protecting a circuit from blowing up when it's plugged in wrong. I've thought of getting some of these to let people have when they're wiring up their own stuff. I haven't decided yet as to, because you can't be absolutely certain that a 0 ohm resistor will blow up and then become unconnected. There is perhaps a possibility that a 0 ohm resistor could blow up and then short, which would defeat the purpose. But that's what these are about. When you see this little thing, it's a resistor, but it only has a single black line on it. That's a 0 ohm resistor. That is the thing that's supposed to blow up if your power supply blows up and protect the rest of the board by sacrificing itself. And again, here we have some more diodes. Diodes are also what we use in distortion devices. We've got our little LEDs, which are also diodes, for showing signal level, plus 22 to minus 30. And generally the way this stuff is operated is by cranking it up super loud or cascading it, like running things like these outputs that plug off the back, the inserts into other channels and just cascading them. So here's the thing. This might be time for me to shut this camera off after I finally got it working. But see this stuff I've been showing you? We're going to talk a little bit about why this matters. Because you can plainly see this is a two-sided board. There's no ground plane. We've got these kinds of op amps in it. And the wires tend to be running in a line, and the wires that are like the buses underneath these are running across rather than up and down. They're tending to run signals at right angles and power supplies at right angles. They're using the two sides of the board to do that. And there's significance to this. So yeah. Oh God. So let me unplug the wonderful HDMI cable and shut this poor camera off. It needs a new cable for me to start doing this properly. Thankfully, I've got some time before I will really gear up to firing up the full circuitry side of things. That's been my intention all this time, is to set it up so that I can get people doing this kind of work. And I've made great strides towards it. And it's like, yeah, clearly there's a lot more. Right now, I have to buy a new cable to be able to do this. But that's fine. So here. Finding where my, yep. Here is a little drawing that I drew earlier, specifically to illustrate this point. I was talking to a friend of mine and explaining what this was about. Suppose you have a circuit board and this line is a trace. You're going from this point to this point, and the trace goes up here, and then over, and then down. And then you've got a ground path. The ground is the black dot here, rather than the circle. And there's a ground plane. And the ground plane covers this entire area. It's on a different layer of the circuit board. It covers this entire area. The question becomes, if you have this, where does the electricity go? Where is the path for the return signal? Because you know the signal that you're sending through this trace is going up and over and down. But the return signal, these are literally, the black dots are connected by a solid mass of copper covering this entire area. If you're running DC current, it will go directly across, shortest path through the copper, the source of least resistance, in other words. And that is significant. But if you have a high frequency, guess where the return path goes? The return path goes up and follows this path, like this. at a high enough frequency. And at a lower frequency, it's gonna round it off maybe a little bit, not go all the way up to the corners, but it's gonna stick around this. And then at a low enough frequency, it's gonna not be drawn towards that path. And at DC, it connects across between the 2 points. The return path for the high frequency signal that follows this square path that's on the printed circuit board. And this is with a ground plane. This is this is stuff that didn't exist when I was in school, even if I was taking acoustics and electronics classes, because this is what PC board designers have been learning. There's a great deal of relevance to this, and a relevance to the circuit board and why this old Mackie has the sound that it does, why it's interesting to people in that way. All this has direct relevance. This is how this is done. You might ask, why would the return path be following this rectangular shape rather than just, no matter what frequency it is, your signal path goes along the trace, and then the return path is always along the shortest path? Again, DC it is. DC, it's the lowest resistance. High frequencies, and remember we talked about op amps, we talked about slew rate of 4 volts per microsecond, gain bandwidth product of 10 megahertz or 3 megahertz, something like that. We're talking about this kind of stuff. Computers need to understand these things as well. The reason is, in order to make the electricity go, we're not actually pumping electricity around like it was a fluid. We are manipulating an electromagnetic field. And it's the field we're dealing with. It's the field that matters. This is similar to like when I'm working with my synthesizer, and I've got all these wires run along it that are just connection to connection, solid core lengths, kind of like what the stuff I'm going to be building in printed circuits or in perf board designs, working with raw chips and stuff, will be based kind of like this. In fact, this is the same wire I'll be using. I've got a lot of stuff wired up like this where you're using thin pieces of 22 gauge solid core with no ground path. All of these are independently grounded. The ground goes through the general power supply of the whole device. On the other hand, these wires, the bigger ones, these are shielded wires, and they do have a ground path. And they sound different from the solid core ones. Here's why. And again, this matters as far as emulating stuff in plugins. This matters in lots of ways. When you're dealing with a signal kind of like this, where it's going along a trace on a circuit board, whether or not you've got a ground path, you're manipulating an electric field. And when you've got the ground plane underneath it, if you're doing DC current, it'll just take the shortest path. If you're doing high frequency currents, it's going to be modulating electric field by manipulating this electric field that is near and around this trace. And this is why they have issues with designing this kind of stuff sometimes, where like digital circuitry interferes with analog circuitry, makes noise. This is part of why expensive converters are expensive in the ways that they are, is because your computer parts can send electric fields into the analog stuff that interferes with it, especially if they're all sitting around in a multi-level circuit board like your phone or something like that. There's so much going on, and they've got to control these things. And you'll have things like ground planes or power planes that go to the purpose of controlling this stuff. So the question that you might ask is, what frequency do you get to where the return path for your high frequency sound is following the trace rather than taking the shortest path? What frequency are we talking about? Like a megahertz, 10 megahertz, where the return path with the ground plane is actually that tightly linked to this trace? Like 20K. I'm not making that up. This is fairly recent discoveries as far as people designing like PC boards that need to not do radio frequency interference. Like 20K. 20K is enough to have the return path starting to follow the trace rather than only going the shortest possible path like you would in DC current. That changes everything. That explains why circuits sound different than the other ones. Here is something. We've got this here. As you remember, you can see right through it. If I had a light under it, anyhow. And you remember how the circuits went in lines and there was no ground plane. And the circuits underneath were going across rather than up and down, typically. This is like point-to-point wiring on a printed circuit board. This is lacking in ground plane. It's lacking in any kind of sophistication as far as that stuff is concerned. And that's one of the first things that they would start changing when they started working with more complicated multi-layer arrangements. So what that means is this is wired up like it's point-to-point. It happens to be printed circuits, but that doesn't change that very much. And there's a bunch of space around all of these wires. And one of the things that's going to happen as a result of that when you have an arrangement like this, and very good, Stephen, you're way ahead of me. This is exactly where I was getting. If you have the ground plane, it's making the electric field have more to work with, and it is lowering the inductance, or whatever you'd call it, of the high frequency being able to go from place to place. If you need high frequencies to move around on your circuit board, you need to have a ground plane or a ground trace that's the return path near it or adjacent to it in order to give it sort of leverage to be able to respond quicker. When you do stuff like, I'd like to, here, I'll grab this. This is not exactly what I had, but this is another, see the knob here? It's a de-Liesel Aventone or something. What the hell is it? It's a switch like one of your old Gibson switches that makes a notch filter. The reason I have this is because one of the things I'm going to do is start plugging this into my synthesizers and running white noise through it so I can measure what this does. Because I intend to make a plugin that is just notches set to these 5 settings. So you can put it in there like for a guitar thing or whatever. It's like, here's my de-Liesel notch filter tone plugin. I don't remember what they called it. It's written right there. I don't care. I built that into this guitar because I learned about this stuff, and I've got this one because I'm going to build it into the Franken Les Paul that I got for $350 because it's a garbage Les Paul. It's not valuable. So it's going to have a special knob, and this is point-to-point wiring. So the deal with this stuff is, and this applies to instrument cables as well as this type of stuff. If you have just the wire and no return path. Yeah, it's going to be biquad price. It's going to be biquad proc, PROC. Yeah, it's not in biquad CPP. It's in biquad proc CPP twice. It's process replacing and process double replacing. That's where you'll find it. I'll talk you through this. I'll show you that stuff momentarily. I'm in the process of talking about some of these things that I've been learning. So the op amps that we have in the Mackie are this kind of op amp that has a strikingly limited slew rate. And then these wires, or printed versions of these wires, that don't have a ground plane, that don't have shielding, because shielding connected in both ends is a return path. They don't have the return path near enough to them to allow high frequencies to go through so easily. If you're using like shielded cables and stuff, that's actually going to give you more highs rather than less. And I never knew about that. Even when I was in college, and that's a lot of years ago, and I didn't finish, but I was doing things like trying to make guitar cables out of zip cord and unlinking it. And my notion about that was I will make it sound better by removing the capacitance, because I knew what capacitance was. And I was doing the opposite of what I thought I was doing, but it still sounded good in its way. Like removing shielding does give you noise and stuff. But when you run audio signals through these individual wires that don't have ground paths right next to them, that is like a form of inductance that is slightly restricting the brightness that you can put through while letting all of the bass through. So the constrained frequency response of this exact board, Mackie Micro Series 1202 original version, the go-to version of this type of thing. It's partly because it's got these op amps which are very extended, but they have slew rate limitations which are really strong. It's extremely slew limited, these guys. They've got capacitors all over the place, these little ceramic capacitors that, if you remember, the stuff I was doing in the plug-in capacitor 2 was modeling the way in which specifically ceramic capacitors, although it might be a slightly different kind, varied their frequency cutoff based on how much electricity was pressing against them. So this board literally has the kind of capacitors that I was doing that work to try to model. Like all the way right down here, you can see these orange things. These are the capacitors I'm talking about. And all through this board, you've got this stuff cutting off high frequency hiss and trying to control it in that way, because that's normal for this type of design. They'll throw this stuff in, it will be a capacitor to ground, and it'll be trying to roll off the hiss by just bleeding it off in that way. And these are the types that might have fluctuating frequency filter cutoff based on how much electricity is pressing against them. And then lastly, no ground plane. Lastly, we've got all these traces going from one place to another, and they're heavy enough traces that it's a reasonably heavy-duty wire, which is not always the case with these types of designs. But there's not necessarily a ground path right next to them. So all of this printed circuit board layout also functions as a high-frequency roll-off, even though, you know, it's transistorized and the actual op amps are extremely extended. So it's like a dark board. It's like a dark, muddy board that you can overdrive that distorts in a characteristic way. And this is what we're after when we're modeling stuff like that. This is what we're after when we're doing that type of work. and figuring out what we're doing. And there you have it. So in doing a Mackie 1202 emulation, it's not so much about doing the exact circuit board as it is finding the places where, and again, like I said, this return path stuff, you start running into this at 20K. I mean, I have the most recent console is rolling off at 20K, and it has some phase irregularities with the filtering because it's a simple biquad, and there were people who were complaining about the tone of it simply because it was rolling off too fast. The actual traces of the circuit board also will start rolling off around the same time. It's going to be distinctly obvious as to what's happening with that stuff. Because all this stuff, you could also call it circuit constants. It's the way the wiring is laid out rather than simply the capacitors and resistors and op amps and things. You can't necessarily model all of that just by doing these circuit parts. You have to also understand where the electric fields are going and how that's working. And people have had to learn this because in recent years, as they started developing ever smaller and fussier phones and computers and things, they'd be in a situation where it's like, I need to develop this thing because it's going to go into an airplane. And it is producing radio frequency interference, and I'm being prohibited from putting this in an airplane for that reason. What do I change to make it stop producing RF? And this is what they've been learning, in relatively recent years. Like, I mean, when I was in school, like 20 years or so ago, nobody knew this stuff. When I was watching the YouTube video about the guy who had been learning all these things over the years and then was giving a little, he was working for some kind of printed circuit board design software that I dare say is very expensive, and making the case for why his software was better than anybody else's. And one of the things was he was talking about what choices you had to make using this wonderful new software to deal with these modern problems that they didn't have mastered back in the day. And the application to audio circuits is reasonably obvious. And it really shows. Like, I have Make Noise O-Coast. It's a synthesizer that they make. You can use it in a Eurorack context, and it uses Eurorack cabling. But it comes as a little standalone guy, kind of like you might get a Moog Mother 32 or something like that. And it is an unusual sounding synth. It is exceptionally clean and pure and clear in the stuff that it does. It's like the hypothetical example of an ideal synthesizer. So I took mine apart, of course, because of course I took mine apart. I had to put it in the actual Euro case, and then take it back out, and then put it back in again, and then take it back out again. I can never decide where I want these things to live. And since I was able to take it apart, I was able to examine it. And this is a much more modern circuit board than the Mackie. It's much smaller. There are more layers to it. And every little section built into a Make Noise O-Coast has its own little isolated ground plane. Like, all the stuff inside it, these little circuits that are analog circuits for the most part. There's digital control to it. You can like power it by MIDI and stuff, but all this stuff that's part of the analog circuits is being protected by ground planes, but it's not one big shared ground plane. Instead, you got like the LFO and you got the oscillator and stuff. Yeah, well, generally I'm logging off in 8 minutes or so. I do not think we're going to get into source code chat today. It's been a ridiculous day. I got through the stuff that I wanted to get through. If you have any quick questions, fire them off, and I'll fire up the laptop and show you where to look. I think you found the process stuff, or if you're looking for AU versions, it's in the bottom of the CPP file. Yeah, make noise Ocoast. It does have a multi-layer, fancier, more modern circuit board. But one of the reasons it sounds the way it does is it not only has the ground plane, which gives all these signals the shortest path to return by at high frequencies. It's not sharing the ground plane across everything. The little separate areas, the ground plane is isolated. There's small channels separating each area from other area. And that can't be by accident, although I'm not really quite sure how the guy arrived at it, the designer. But it's clearly a reason why that particular circuit has an exceptional sound, because that circuit has an extraordinary purity of sound. Its little triangle waves and stuff, everything that it does is exceptional as far as the clarity and sonority of these things. And you can do that stuff on purpose. Although there is the other path, rather than having the ground plane and having everything extend up to the super duper high frequencies cleanly, like the make noise stuff does, you can also do point to point, have no ground plane, have no return path, and have it be old school. And again, like we've been talking about for the last couple of hours, that gives you stuff like this. And I know where I can get the same kind of op amps that go into this. They won't look exactly the same because those are single inline pair, and I'd be getting double in dip ones like my other circuitry. But I can get these op amps in quantity, so that might be a thing depending upon how much people like their homebrew synthesizers having that classic like old drum and bass vibe. Because if you're going to build stuff like this, you might as well have it vibe the way that you want, rather than deal with like limitations of some kind. So that's probably all I've got for the circuitry. And price, I'll catch up with you perhaps next week. There were things I was going to do. The feed forward verb thing never ended up happening. It's been too difficult of a day to do that, but that's fine. Bo, you're probably sticking around a little bit longer. I'm not going to, after a session like this, I'm not going to go for hour after this. Although I'm thinking about firing up some other streams. I just haven't decided literally everything I'm going to do around it. But I might be able to answer some of your questions, Bo. Let's look at some. Yeah, sure, there we are. So, wrangling stuff. Hi. EQ code, you say. Let's open an EQ. ASM. I don't have an ASM. See? There is nothing that says ASM there, so I can't open that. It doesn't exist. So the question becomes, what EQ code would we like to look at? We'll look at some and I'll explain how it works. And then I will log off and go lie down. A number of these, like the biquads, is less easy to explain. Do you want one that's real easy to explain? or one that is more difficult to explain, or super, super difficult to explain? Yeah, awesome. Okay. Like, name a plugin. I'll tell you what it uses. Because again, as far as EQ type things is concerned, there is a variety of. Let's look at some of the early stuff. How about some of the things I did first? Here's something that I did a long time ago. One of the first ones I ever did. Drive. And again, this is price. This is where you find the AU code. It's in drive kernel process, which is right down at the bottom of this file. See, top of the file, controls, initialize and reset is where you start things. As you can see, this is IIR sample A and B, which will enter into what I'm telling Bo about. And then on downwards to here. So what we've got here is a thing. I'll type new stuff into here. We're making a number which is associated with the sample rate. Like, it'll be 1 if the sample rate is CD or this. And if it's a higher number, then it'll be like 2 times the sample rate, so it'll be 2 or whatever. We've got a number here which is going to relate to how the filter works, and it's called IIR amount. Param 0, param 1, 2, 3, and 4. These all go, well, actually 1 goes from 0 to 100. A lot of these go from 0 to 1. We'll assume that they all go from 0 to 1. Because like this drive 1 is part of the distortion. That's not the part we're talking about. So we know that param 2 goes from 0 to 1. Pow get param 2, comma 3 means param 2 times itself times itself. It's param 2 to the third power. What that means is that it is going to, if it is smaller than 1, it's going to become much smaller than 1. And if it's larger, if it's larger than 1, it will become much larger. Since this is 1 or smaller, it's going to become much smaller. And that matters because that helps us scale the equalization a little bit. And what we've got here, I don't know whether I want to make a whole new project just to do this. I think maybe not. I think that's a terrible idea. See this up here where it says high pass section? That is a filter. Let's take this, we'll build it once. It'll throw a bunch of errors initially because that's what the AU does. And then we'll start playing with it. We can barely play with it because I never even turned on my speakers, but my laptop is here, so I can hold the microphone right up to the laptop, and that'll do for now. That's as good as we're going to get today. Can build succeeded. Let's go to where we found that, which was in plugins. Not Win, but AU. We'll go to drive, we'll go to build. There, we just built that. See, it says 2.1.21. So we put it into components. It asks if we want to keep that, and now we're using that as a equalizer. So what I'm going to do is rapidly do a couple of changes that simplify this. But what we've got right now, what shipped as Airwindows drive, was this. Without drive, this is the distortion part, right? On the output level, this part marked high pass takes the bass away. Now, how's it doing that? Well, we'll find out. This is part of what we're doing in filters. Let's start simplifying this. Firstly, I'm going to use a C language thing. This is what they call C-style commenting. Now I've taken this out, so I'll quickly build it and show it. This is one nice thing about having old Macs, is that it'll let me do this. It'll let me just alter it. Fire this up again, go back to the same thing, which we've now changed by commenting this stuff out. Therefore, this doesn't do anything anymore. We commented out the thing that was changing the tone. I'm going to crank it way up because I'm stuck with using just the laptop. So we've still got these variables sitting around. What would happen if we took some of this stuff What does this do? This says IIR sample A equals this plus this. Let's break it down into two statements. IR sample A equals IR sample A times this. IR sample A equals IR sample A plus this. And what's this? This is two variations on this thing. It's IIR amount, which, as you remember from up here, is a number between 0 and 1 that will tend to be really small. What happens when we have something called IIR sample A times something very small, or 1 minus something very small? It will get littler. What we're doing is taking what we had before and taking some of what was there. Say we've got, let me draw more stuff. Where's my pen? It's over here. Say we've got this, and we've got IIR sample A. If it doesn't change, it just stays here. If we've got some really tiny amount, like IIR amount, and it's a little tiny bit, it's like from 0 to 1, it's almost nothing. We're not needing arrays for this. If you take IIR sample A, and this is from 1 to 0, and you multiply it by this part, it becomes a little smaller. It goes from up here to down here. It's gotten smaller by the amount that it was multiplied by, which is not entirely 1. It's a little bit littler. Then if we've got a new signal coming in, and the new signal is multiplied by the tiny amount to become much smaller, and then we add that to what we had, well, supposing it was exactly the same, it will get smaller and then go back up again. But supposing it was something really small, it would get smaller and then just stay smaller. You got this entire audio signal, and then if you're making it smaller, it becomes a tiny audio signal because it's less loud. It's amplified by a small amount. and it'll go from a big area to a small area up here, which you're adding to what you had before. Here's where I'm going to give you something to listen to as well. We've just written this in here. That means IIR sample A, going back to that. That's what I just drew on the paper. IIR sample A times 1 minus very small number, which was up here. The small number we change by moving that slider. It can get kind of big, but mostly it's going to be small. So this is making whatever we're storing here a littler. Then we're adding our audio waveform coming in, input sample. If we don't change that, that's just our audio. It's going to fluctuate between around -1 and +1 and center on 0. And if we listen to the output, like if we listen to the input and that's just the output, then we have the music coming through, it's the audio again. But if we have this instead, now we have input sample equals IIR sample A, which wants to stay in one place. It wants to stay the same most of the time. Most of it's going to be the same as what it was before, but we're also introducing small amounts of input sample. Can you guess what this will do? It's not the same as what it did when I started doing this stuff. We'll compile it. We'll drag it to the components folder. We'll fire it up. We'll hold the microphone directly against the laptop speaker because we'll have to. Now our high-pass control hear that? That's pretty nasty sounding, but we're distorting the laptop. So it's bright here. Less and less. And we can see there's just a little bit, and at 0, we got nothing. So what's causing this to happen? At 0, there's nothing. There's no sound. Although it will hang on to any DC offset that was there, which is a concern with some of these plugins. As we introduce it, we start getting low frequency sounds. And as we keep including more of input sample. Remember, IIR amount is small when it's down near 0 and bigger when it's turned up way high. And if it's cranked up all the way, what you get is IIR sample is always 0 again. It's itself times 1 minus whatever this is. If this is turned up all the way, it becomes 1, meaning that we make this be 0 automatically. And then if we've turned it all up all the way, it's become nothing. And then we add, and another way of saying this is this. Plus equals is a way of saying take this and add what we've got here. Now there's another thing we can do here, which is this. Remember how this was making a low frequency filter? that it was making stuff be darker or brighter. If we change it to be this, now it's just always going to be input sample times IIR amount. What's that going to sound like? It's not going to sound like a filter anymore. Instead, we've turned it into a simple gain control. And that works kind of like this. See, it gets quieter or louder, but the high frequency stuff is still there. You can kind of still hear it. This is now a volume control. What made it be a tone control, what made it be a filter, is that it was keeping some of what was already there. And this also applies to the biquad filters and stuff as well. They use this same principle. It's keeping what was already there and adding some of the new stuff. The more of what was already there it keeps, the more it will tend to favor bass frequencies and not have high frequencies. Because bass frequencies are the things that change slowly from sample to sample. They'll gradually wander to a larger number or a smaller number. And high frequencies are the stuff that changes rapidly. Kind of like with the slew and so on. Slew is how fast this stuff changes. Now there's one more thing here. Because if you remember, this was not a low-pass filter. This was a high-pass filter. It's a little complicated because it has this thing called FP flip, meaning that it's doing every other sample. But I've made a version of it here, which is just the simplest form of filter you could have. And again, in this formulation, it's doing IIR sample A. It's giving either small amounts or large amounts of input sample, which is our stream of just the audio we're working with. And it's retaining however much of itself that our IIR amount control is set to. So if it's letting only small amounts of input sample in and keeping most of itself, it's going to be low frequency emphasizing. And if it's letting large amounts of new stuff coming in and keeping very little of what was there before, it's going to emphasize high frequencies, or at full crank, it's just the input sample again. This is also a way that you can do averaging. Averaging is basically IIR sample A is the last input sample, and our output becomes, take the last one we had and this one, add them together and divide by 2. That is kind of what you get when you have IIR amount be a half. Like, instead of this, each one would be 0.5. If we do this, then it no longer controls the slider no longer does anything, but this will actually work, and this will be a kind of filter too. It will not be an averaging filter because it continues to hang on to earlier stuff, but it's a darkening filter. And I can show you that. See, this no longer does anything. But with exactly half of the original one and half of the new sample coming in, we get this. You can hear how it's kind of brighter. In order to get a real low-pass filter, you have to keep much less. Like, for instance, if you were to do old sample that we're sticking with is 0.75, and the new thing only gets 0.25, that's now going to be darker than it previously was. Same deal. Fire it up. So now when we do that, much darker than it was. Or the previous sample is 0.95 and the new information coming in is 0.05. That's very little new information coming in. What that's going to do is be a lot darker. Hope you're following this, Bo, because you're the one I'm doing this for. Although anybody who is interested in your very most basic EQ design, this is probably useful, I suppose. This is a good enough thing to do, seeing as we're not going to be able to do real coding today. And we've now set it up so that with 95% of the original value and only 5% of all the new stuff coming in, it should make it be a lot darker. And IIR thingy is the sample value that's being stored. So again, dry. We've now made most of the brightness go away. It's storing sample values in a single variable IIR sample, technically IIR sample A. With the real version, we've got two different ones and it's interleaving it, but that's another story. This is simpler. So now how did we get the high pass? As you can see, what we've got here is IIR sample A is stored. We set it to 0 to start off with, it's silence. It's going to be kind of chasing what the new information is coming in. This is how it's chasing new information coming in. It's like you're pulling the variable along with you, sample by sample. And every new thing that comes in, if it's way bigger, it's like, okay, we're going to mostly stay the same, but then we're also going to go a little bit towards this. Or if it's way smaller, okay, we're mostly going to stay the same, but we're going to go a little bit towards this. It's like it's pulling it in various directions. And when you listen to the output, what you get is that low-pass filtered thing, where it's not going to be able to do sudden motions. It's not going to be able to do high-frequency stuff. But it is going to be able to do sort of low-frequency chasing what the information coming in is going to be. If you do multiple stages of this, it will get a steeper filter angle. And in fact, we can do a little bit of that. Since we have two things ready to use, we'll do it twice. Here, see, we've done it twice. So we're doing the IIR sample A. That's chasing what we're doing. And we're making our audio path, which we're listening to input sample when we're done with all of this, be the being chased version. And now we're doing it again with a different sample. If we do this, we have now added another what they call pole to the filter. It's gone from being 6 dB per octave to 12 dB per octave. It's mostly the same frequency, but the high frequency stuff that it's eliminating is getting cut off more effectively. The filter is steeper than it was. And the way that sounds is like this. We've got the same cutoff frequency, which is, in this case, 95% what was already there and 5% whatever new is coming in. And then we're doing that twice in a row. So it's going to have the same cutoff frequency, but it's going to go steeper. But where did the high pass come from? I'll show you. By firstly getting that out of the way. We have this low frequency thing, right, where we're doing this, we're making stuff be duller, and we have IR sample, which is just the slow stuff of the input coming in. If we do this, then what do we get? Input sample is the information that was coming in. It's the full brightness. It's the no filtration at all. We've made IR sample, which is about the same, or very near to being the same, but its high frequencies are taken away from it. That means now we have input sample still, until we do something else with it. And then we have IR sample. IR means infinite impulse response. It's literally what we're doing with this sample chasing the input stuff. If we have input sample equals input sample minus IR sample A, remember this was the one that was darker. This was the one that had less high frequencies, and it was just the low frequencies remaining from what we took with our input sound. Now, if we do the same thing over again and get back into this, bypass, here's our audio, and now if we engage it, we don't really hear anything very much. But I'll tell you what. Let's go back to 50/50 again. Now we have IR sample A. It's 50/50. This was set up before so that I'll just cut this off. Build it. Same deal. Now we should have it if this works. It's very bright. It's just a little bit less bright. Now we do this, and we get this slightly less bright, but still most of what's there. And we go input sample equals input sample minus IR sample A, also known as input sample minus equals IR sample A, which is the same thing as input sample equals input sample minus this. And remember, it was mostly very bright. It didn't change much. Now if we do this, I think I was crossing it over too low before. We should get Now we're taking away the lows instead of the highs. Now it's just that bright stuff. Not only that, we can double that sucker up too. Again, multiple poles. If we do the same thing over again, pick the same frequency, and we're doing it twice. And then minus equals IR sample B. Again, same thing. This filter is the same as this filter, different retained sample. IR sample is the one that we keep and keep modifying. But now we're in two poles of this. It's going to reject the low frequencies even more because we have two poles of this filtering. And you can do lots of those. There are versions of old plugins I've done where I did like A through Z. I did 27 poles of this primitive filtering, which is not actually as good as biquads, but it's simpler. And that's what I started off with, was a bunch of very simple stuff. So double poles of this low frequency remove and stuff. That is how that is done. And you had one question which I will handle before calling it a day, I think. We're doing a multiplication with a negative IR sample A do a thing. Let's find out. We've got IR sample A. Now we have IR sample A is the slightly filtered one. In fact, we can put it back to the mid-rangey one because I think we're going to need to. Now we are multiplying input sample, which is our input audio again, by our slightly filtered audio, but we're also doing it a negative version of that. And let's see what we get. I'm going to guess this is not what you expected. We're going to find out. This is a good way to go. Like you need to be able to make a plugin that'll compile and then start trying this stuff and see what it does. There's also ways of doing things like this in like Faust. You can do it on the web now, stuff like that. So bypass, here's what we got. Multiplied by negative IR sample A gets you this. Why did it do that? Because this is not simply filtering anymore. IR sample A is just a basier version of input sample, but when we multiply input sample by IR sample A, it's not different. It's only slightly different from, say, input sample times input sample. And I'll show you what that does too. It does a couple of things, in fact. And they're interesting things too. Firstly, we'll hear it. Here's the regular sound. What's happening here is if the signal is at 1 and it's multiplied by itself, then it stays at 1. So our loudest sounds are unaltered. Quiet sounds are being multiplied by themselves And since they're a smaller number that is nearer to 0, they're getting even smaller still. So they're becoming much quieter. This is a sort of peak generator. It's making the quiet stuff go away. Normal sound like this, altered version like this. And this is not that dissimilar to what you get out of, say, console bus. It's doing a similar thing of making stuff be more peak heavy. It's the opposite of saturation. But wait, there's more. Because if you were to, say, take a little chunk of it and let's make a new document with the selection and let's zoom in so we can see it. Let's crop to this so that it can be bigger. Look at these waveforms. Here's a waveform. Now, what's going to happen when we do this multiplied by itself? A couple of things, and here's one of them. We've also made all of the outputs only positive. So all the quiet stuff becomes much, much quieter. But all the negative waveform sweeps can only become positive because it's negative something times negative something. It's flipping the result. So we have a peak heavy thing. This is no longer equalization. And if we were to do this multiplying the input signal with a IIR sample A or a negative IIR sample A, same deal, it won't matter. It will wind up being one-sided only, and it'll wind up being quiet stuff is much, much quieter. The reason is because we weren't adding, we were either taking IIR sample and just using it directly, and that gives us the high frequency roll-off because it's basically being dragged around by what the input sample is doing, and it might be getting dragged around very slowly. So if we just take the output sample from our filter thing, it just becomes darker. Or if we take the input sample and subtract the more slowly reacting stuff, we get that high frequency stuff. But at no point are we multiplying input sample by another waveform. Or indeed, here we can do something even crazier. Let us make a big mess, and I'll probably call it a day after that. Multiplying didn't work. How about dividing? And let's divide by IIR sample A, except for we can't actually divide if it's 0, because you can't divide by 0. So what we'll do is we'll just say hang on. So what we'll do is, yeah, we're going to explode. It's going to explode real good, but it'll be fun. Again, this is using our filtered stuff. It's a filtered version of this, but let's make it even more filtered. If we make it be super duper filtered and we used it directly, if we listen to IIR sample A, this would be just all bass. But it's not. Instead, it is input sample divided by whatever this very bassy thing is. That's typically going to be a very small number. And the bassier it is, the closer it's going to get. And if you divide by a negative number, you're going to be flipping the polarity. So this is going to be a big mess. And we're going to find out what it does by compiling it and running it. This might be why my laptop doesn't sound good anymore, is because I've done too many of these things that hurt it. Regular sound like this. Divide sound. It just died. Oh no, wait, no, I never actually. Divide sound. So that's deeply terrible. We could do the same trick we did before of make a new document. Apply this, and we just got pretty much nothing but full crank blast, which is generally what you would get if you divided by the same thing that you had, is everything just becomes ones or negative ones. So what we could do now is play with this by bringing back in IAR amount. Our slider will now work again. And that is because our filter now is keeping track of what's going on there. So we can make it be basically the same thing as input sample, or we can filter it down until it's nothing and only has low frequency stuff. But we're still going to divide input sample by our heavily filtered sample. And let's see what we get. Because it's not going to be an EQ. I'll put it back to EQ momentarily and then call it a day. But this is what you're going to be doing, Bo, if you start doing this kind of stuff. Is here's a new document. The sound of our new mess is like this. Interestingly, this is nothing except for its full crank. So this is the output of like 1. So if we applied this, we have pretty much utterly smashed and overblown distortion. What did we have when it went silent? Let's undo. And have a look at what would happen when we made it go completely silent. See, it's getting brighter and brighter. Let's pick this. This is just a bit of noise. What's this noise actually that we're listening to? It is almost all the sound at full +1 with almost never any variation anywhere else in the sound. So we basically have a DC offset as our output to this thing. And that's what it looks like. That little crackly noise was these voltage spikes coming through all the time. And that's because we're dividing. That's because we're doing this kind of stuff. And again, if we return to effectively what we had in the actual plugin, and this is a simpler version, but it's much the same as what was originally there. We will have our original filter back again, high pass, with a little control for it. Now, one thing I can point out, this is going to remember what the setting was. So if I set it to 0.9, listen to how bright that is. Now, if I return to the original code, now we've gone back to what this originally was. This is drive as you have it in the plugins. And back to normal. Now remember how bright that was? It's not quite as bright as it was. That's because it's an interleaved filter. So the rolling off can't happen quite as much as it did when it was doing it literally every sample. It's two different ones, and each of them have to do every other sample. It's interleaving, it's swapping back and forth between them. And that's part of how the filter in drive and density gets its sound. And there you have it. So yeah, this has gone a little longer than I planned, but honestly, I feel it was time well spent. L2Q had a quick question. Aren't knobs technically in the same group as DAW fader? Yeah, they would be. Nothing's perfect. You do the best you can with stuff. Now, if we were to get into other forms of EQ, that would get progressively more complicated. But still, you got to start somewhere, and this is where I started, is with simple forms of filter like that. And a filter is basically a way of coming up with a different answer for what the output of the plugin is going to be. Like, say you start with input sample, and let's assume that you're going to end with output sample. What would you do to have the numbers be different? You could have it be just like output sample equals input sample, or just directly output, and that will be no change. On the other hand, if you were doing something like having a variable that is kept between samples, it's kept between buffers, it just stays, and having it slowly pursue wherever it thinks the sample is, that's going to be a low-pass filter. Sudden motions aren't going to be able to move it, but it will gradually catch up to where the audio is. And if you have that going on and it's at the correct volume level, and then you subtract it from the original stuff coming in, that's a high-pass filter. That has made the low-frequency following go away. And you're left with only the sudden motions that aren't represented in the slower stuff that's following along. And if you were to do that with two filters in a row, like first you filter off the low pass, first you filter the high pass by making the slow following thing and then subtracting that, and then you take your resulting thing and then you have another slow following thing, maybe a little higher frequency, and have that be the output of the slow following thing directly, then you have a kind of bandpass filter. It's going to get rid of the lows because you did that in one part, and then it's going to get rid of the highs because you do that in the following one part. And you just sort of build stuff that way. Things like biquads that are much more complicated are basically that with some more levels of detail. And you're essentially constructing things out of these building blocks of this is a low pass, this is a high pass, this is kind of both at once, so it's going to be mid-range, or this is a notch filter, it takes away this is a notch filter, this is an analog notch filter. The high frequencies have to go through a capacitor, which only lets through high frequency stuff, and then also a inductor, which only lets through low frequency stuff. So when you wire these together, you end up being able to send only a narrow band, the resonant frequency of both of these combining, to ground, filtering it out, making it a notch filter. Another thing you can do is wire it up in such a way where the high frequencies, the capacitor, and then the inductor, and that goes through to the output, and you only listen to that part, and that is a bandpass. That is a resonant bandpass, and it sounds kind of like a wah pedal. That's how wah pedals are made. All this stuff is the building blocks of EQs and such, and EQs are the building blocks of how you make tones and sounds and things happen. So on that note, this has been a really insane day. I hope people have enjoyed how crazy it was. Sorry about how it was never actually a feed-forward reverb thing, but I'll catch up on that later. And I will get ready to power my OBS stuff down. Hopefully it remembers how to work next time I try to use it. It's weird that it suddenly changed its mind about how everything worked. Go figure. And I will say goodbye to chat, and I will say goodbye to you, and talk to you later.